Hello everyone, welcome to Supre's Easy NEET. இந்த வீடியோல நம்ம capacitance form chapterல இருக்க formulas எல்லாத்தையும் ரிவைஸ் பண்ணலாம். And every year NEETல இதுல இருந்து minimum 2 questions கேக்குறாங்க. So let's revise the formula. First formula Q is equal to CV. Q is the charge on positive plate of capacitor. C is the capacitance of the capacitor and V is the potential difference between positive and negative plates. And representation of capacitor symbol பார்த்துக்கோங்க. Energy stored in the capacitor formula U is equal to half CV square, which also Q square by 2C and also QV by 2. ஸோ இப்போ அவங்க கொடுத்துருக்க டேட்டாவை வச்சு நம்ம ஃபார்முலாஸ் யூஸ் பண்ணணும். இப்போ சப்போஸ் கெப்பாசிட்டன்ஸ் அண்ட் பொட்டன்ஷியல் டிஃபரன்ஸ் கொடுத்துருந்தாங்கன்னா எனர்ஜி ஸ்டோர்ட் இன் கெப்பாசிட்டர் இஸ் ஈக்குவல் டு half CV square. And if they have given a charge and capacitance, we have to use Q square by 2C. Like that we have to use. And next, energy density is equal to half epsilon naught epsilon r E square. Also, when they have given dielectric medium, we have to use half epsilon naught K into E square. Then for vacuum, energy density is equal to half epsilon naught E square. Next, types of capacitor. First is parallel plate capacitor. Formula of parallel plate capacitor. The capacitance is epsilon naught epsilon r A by D. If they have given dielectric medium, then we have to add K. K epsilon naught A by D, where A is the area of plates and D is the distance between the plates. Next is spherical capacitor. Formula of spherical capacitor. The capacitance is 4 pi epsilon naught r into r. Capital R is the radius of the spherical conductor. And if we have two spherical conductors like this and radius A and B, the formula of capacitance is 4 pi epsilon naught AB by B minus A, and they have no dielectric medium. If in see in the second diagram we have dielectric medium, so we have to use this formula. C is equal to 4 pi epsilon naught K2 into AB by B minus A. Why K2? Because K2 is the dielectric medium present between A and B radius. So it's very important to note this formula. And next, cylindrical capacitor. Capacitance of cylindrical capacitor is 2 pi epsilon naught ln B by A into F by M. Next, capacitance of capacitor depends on area of plates, distance between the plates, dielectric medium between the plates. Electric field intensity between the plates of capacitor E is equal to sigma by epsilon naught or V by D. We can use any of these formulas by data given. Next, what is the sigma is the surface charge density. Next, force experienced by any plate of capacitor. F is equal to Q square by 2A epsilon naught. Distribution of charges on connecting two charged capacitors. So when two capacitors C1 or C2 connected, first in this diagram see positive A, B and a capacitor and another capacitor C2 has been C1 and C2 are the two capacitors, and A Q1 charge and minus Q1 charge A and B, and plus 2 Q2 and minus Q2 C and D initially. So initially, and again this is final charge Q1 dash and plus Q2 dash and minus Q2 dash. So the common potential will be C1 V1 plus C2 V2 by C1 plus C2. Total charge by total capacitance. So total charge is equal to Q1 plus Q2, right? So what is Q formula is C into V. So Q1 will be C1 into V1 and Q2 will be C2 into V2. So we are applying it in it. Next, Q1 dash, the final charge. What will be the final charge? C1 into V, that is common potential. C1 into Q1 plus Q2 by C1 plus C2. In Q1 we can put C1 V1 and in Q2 we can put C2 V2. Again same formula for Q2 dash. Final charge on Q2 is C2 into V. C2 by C1 plus C2 into Q1 plus Q2. Heat loss during redistribution. Heat loss is delta H and it is equal to initial energy minus final energy, which is equal to half C1 C2 by C1 plus C2 into V1 minus V2 the whole square. And the loss of energy is in the form of joule heating in the wire. So it is in the form joules. Combination of capacitor, we know this we have studied even in resistors. So in series combination, it is the reverse of resistance like that. So 1 by C equivalent is equal to 1 by C1 plus 1 by C2 and so on. And V1 is to V2 is to V3 will be 1 by C1 is to 1 by C2 is to 1 by V3 in a series combination. And see in parallel combination, C equivalent is equal to C1 plus C2 plus C3, and Q1 is to Q2 is to Q3 is equal to C1 is to C2 is to C3. And in the series combination, we have all charges are same, and in parallel combination, we have all potential difference same. Potential difference is same everywhere. And charging and discharging of capacitor. Charging of capacitor initially uncharged. So Q is equal to Q naught into 1 minus epsilon naught T by tau. So Q naught is equal to CV, which is at a steady state. And tau is the time constant, which is equal to capacitance into R equivalent. And we have another formula, I is equal to Q naught by tau into e to the power minus t by tau. Or Q naught by tau, we can write it as V by R into e power minus t by tau, because Q naught is equal to C into V and tau is equal to C into R. So C got cancelled and V by R into e power minus t by tau. Just go through the graph, and the average is 0.363 Q naught. Discharging of capacitor. Q is equal to Q naught e power minus t by tau. Q naught is the initial charge and I is equal to Q naught by tau e power minus t by tau. And you can see the diagram, zero average is 0.37 V naught. Capacitor with dielectric. So in presence of dielectric medium, the capacitance will be epsilon naught A into K by D or K into C naught, initial capacitance. That is in absence of dielectric. And electric field inside, in absence of dielectric, is equal to sigma by epsilon naught. Presence of dielectric is equal to sigma by K into epsilon naught or equal to V by T. Sigma B is equal to sigma into 1 minus 1 by K. Next, force on dielectric. When battery is disconnected, F is equal to epsilon naught B into K minus 1 into V square by 2D. B is the breadth of the dielectric medium. So B is the breadth of the dielectric medium. So epsilon naught B into K minus 1 into V square by 2 into D. When battery is not disconnected, F is equal to Q square by 2C square into dC by dx. We have to differentiate the capacitance. The force on dielectric will be 0 when the dielectric is fully inside. So force will be 0 when dielectric is fully inside like this. Okay. So force on the dielectric will be 0. So that's all. And if you have studied this formula, you can attend every question from capacitance. So practice, so it will be easy for you. Thank you guys. Thanks for